welcome back. In this video, I will continue with the topic about polar coordinates. Before I get into the lesson, please let me reminding you about the my website. You can visit my mathteaching.ca. I wrote it on the top. To see on the weekly lesson, I posted there. I try to post them in the order, but maybe it will mix a little bit, not like quite in the order and sequence like you get into my full courses. But however, if you just curious and you're interested in seeing something new, just visit it. And if you like, you can subscribe to my website. And I post there the poem sometimes and quote of the days and quote of the weeks with some of the interesting video and pictures as well, not just the math lessons. So even though you're not a math type person, maybe you can take a look at it and see if you like it. The next one is you can purchase the full set of course, and I'm about to publish the second one because this is the last section in the last unit in the second calculus course. I hope that I can publish as soon as possible, but however, I have to be careful and go through on the quiz I make and on the quizzes and on the unit quiz, on the final exam, and make sure the solution there, we check it for you. So before I publish my course, gonna be another week or 2 weeks, then this course will be soon published. And I hope that you can take a look at it. Anyway, let me get into the lesson now. So I have shown you in the previous video today, I have shown you how to converse between the polar coordinates and the Cartesian coordinates, which is the X and Y coordinates. Regularly, we have seen them a lot. And then I show you how to converse to polar coordinates in the form of the radius of the unit circle and then the angle theta. So now in this lesson, follow up with it, and I will show you how to convert a polar equation to a Cartesian equation and vice versa. So we will go forward and backward as well. So let's take a look at the question I wrote on the board. Find the Cartesian coordinates of the curve with the polar equation. So given us the polar equation, verify the Cartesian coordinates in this question. So how are we going to do that? Now, obviously, this is the polar equation, right? Because we have a radius here equal -6 sine theta. So the hint here is I'm going to multiply both sides with another r. So I will time this with another r, and I tie this with another r. So here on the left side, I will have r squared equal -6 r sine theta. Now remember the r sine theta here, we also can convert is become, for this r square, we can make it as x squared plus y squared, right? Remember r equals square root of x squared plus y squared. So r squared will be equal, r squared will be square both sides, right? So therefore r squared equal this, right? X squared plus y squared equal -6, and I'm going to change this become y, right? r sine theta equal y. So I will change it become y. So now, what do I have? I can transfer the equation. I can move this over, and therefore I will have x squared plus y squared minus transfer to here become plus 6y and equal 0. Now at this point, I want to give it to the equation of circle, right? Everybody remember the equation of a circle is x squared plus y squared equal r squared. This is the equation of a circle, right? So I'm going to from here, I'm going to give this a try as an equation of a circle like this. But how do I do that? I have to do completing perfect square. Now, the completing perfect square, we have learned this topic in Math 10, but we're going to do it here, right? So we will have x squared plus, to do completing perfect square, I divide this by 2, so I know my a is y, and my b is 3, and I square both of them, right? That's how we do completing perfect square. But when doing this, we toss in the extra term, which is original we don't have. We're missing the last term in here. But when we square that last term, we got 9. So in order to compensate for what we're doing here, we toss in this bracket. So we toss in an extra term, which is plus 9. So therefore, to compensate for it, we have to do minus 9, right? If you learn already the process of completing perfect square, you know what I'm talking about, right? Other than that, you will say, oh, wait a minute, why it's like this? Now, I don't want to go through the whole thing to finish the completing perfect square. That is another topic. But at this level, you should not be able to do the completing perfect square, which is we toss in an extra term, which is plus 9. We take away minus 9 so that we don't make mistakes. And that's the way it is, right? So now I will have this equation, something like this, and I'm going to move it over, equal 9. So this 9 here actually is my r squared, and this is the equation of a circle, right? So this is an equation of a circle with the center, What the center here? The center is, for the x, the center at 0, and for the y, the center as -3. So the circle will go through this point, right? Because this is one point on the circle. This is at the center, actually, center point of the circle. So now you'll be able to do this. It say find the Cartesian coordinate. So this is the Cartesian coordinates of the curve with polar equation. So given the polar equation like this, we are developing this, and we end it with the coordinate of the center of circle. Now, if you want to get to another coordinate, all what you do is substitute any number in this form, you will be able to find another coordinate, right? If you substitute any value of x and y in this equation, you will get another point. But this is how we answer it, right? Okay, so I hope that is clear to you. Now I'm going to go to the next question, right? The next question is we go backward. Here, problem 2, they give us the Cartesian equation. So therefore, we have to convert to polar equation. So instead of doing Cartesian, now from the Cartesian, we go backward, we go to polar equation. So I'm going to mark here, okay? we have problem 2, right? I'm going to copy down the question, x squared plus y squared plus 4x equal to square root of x squared plus y squared. Now, to go back to the polar equation, we have to go into some form look like this, right? This is the form of polar. So we want to go from Cartesian to polar, we have to lead them into this form. And how do we do that? Now, x squared plus y squared already in the form of r squared, right? R squared equals x squared plus y squared. So I'm going to replace this by r squared. Adding with 4. Now the x, we also know that x equals r cos theta. So I'm going to replace this by r cos theta equal. This is going to be 2 here. Now this one is r, right? Just r. This is r. R equals square root of x squared plus y squared. So that's very much almost already there. Now I'm going to say divide both sides. Divide by r both sides, right? So r divided by r squared divided by r will be equal r for this number. Adding with 4, r cos theta divided by r will be just cos theta. Equal 2 divided by r is just 2. So now you can move this root over. So you can have r equal minus 4 cos theta plus 2. And this is the polar equation. So we're done. Now I'm going to do the problem 3. So this is problem 2, right? We're done with that. Now I'm going to do problem 3. So here we have x squared plus y squared on of this square again outside equal 2x squared minus 2y squared. So how do we convert into polar equation? Oh my cat. He just okay, sorry for the noise. Okay, so x squared plus y squared power 2. Happy, what are you doing? So x squared plus y squared to power 2. This one is r squared already. And then we square again, right? So the whole thing here will be equal r to power 4. Will be equal, this I'm going to change into r cos theta, right? So it will be equal to r squared cos square theta, right? Because it's not an x, but it's x squared. So it has to be this. Minus 2, the same for y squared, I'm going to change into sine theta. So 2r squared sine square theta. So at this point, I will divide both sides by r squared. So if I do that, I have to erase some of the board here so I can have the So I'm going to continue with this. So divide both sides by r squared. We will have r squared. So r4 divided by r squared equal r squared equal 2. The r squared will gone because we divide with r squared. 2 cos square theta minus 2 sine square theta. So now at this point, I almost done. I'm going to factor out the 2, and I have cos squared theta minus sine squared theta. So now, remember the identity of trigonometric function. This will become 2 cos 2 theta. And this is my polar equation form. So again, this is another short video for our bonus unit question, unit section in our second course. So the first video, I show you how to convert from Cartesian to polar coordinates and so on, and go backward. In this equation, in this lesson, I show you how to convert from the given polar equation. We convert back to the Cartesian equation, and vice versa, backward as well. So here I show you how to convert from the Cartesian equation to polar equation. And there are 2 questions. We convert from Cartesian equation to polar equation. So this here is a polar equation. So because the main point in this section is this lesson, I just want to introduce to you before we get into the main point. The main point of this section is the next unit, which is how you show you how to sketch the polar curves. This stuff is just the extra work I taught in this section. Our purpose is how to draw, how to sketch the polar curves. And that will be done in the next video. So I hope you enjoy our video today. And thank you for watching. See you in the next video. Please hit like or subscribe. And if you want to visit my math teaching channel online for learning or for curiosity, just please go to my mathteaching.ca or mathcourses-online.teachable.com. Thank you and bye for now.